How do you ensure security in microservices? To ensure security in microservices, we should use strong authentication and authorization to control who can access services, encrypt data being sent and stored, and communicate securely using HTTPS. Keep services updated to protect against vulnerabilities, restrict access to the minimum needed, and continuously scan for security weakness. Logging what happens within the services also helps quickly spot and address any security issues. What are the common security patterns applicable in microservices? In microservices, common security patterns includes using an API gateway to handle and check incoming requests, setting up services to services authentication with tokens or certificates, and gradually securing old systems with the strangler pattern. It's also important to encrypt data being sent and stored, regularly check for security weakness, and use the sidecar pattern to add security features to services without changing their main code. These methods help to keep the system safe. How can services securely communicate with each other? To make sure services in a microservices system talk to each other securely, they should use HTTPS, which encrypts data sent between them. Mutually, TLS is a good method. Provide both encryption and authentication to make sure only allowed services can connect. Also, using an API gateway helps to manage and secure communications, and using access controls or API keys confirms the identity of services before they can communicate with each other. What are the implications of service-specific databases on security? Using service-specific databases in a microservices setup can make the system more secure, because if one service gets compromised, the breach affects only that service's data. Each database can have security settings that fit its own needs, which helps in protecting sensitive information better. This setup also for a easier management of who can access what data. However, it requires careful management to ensure all databases meet the security standards and prevent unauthorized access. Discuss a pattern used to handle failures in microservices. In microservices, to manage failures, several patterns are used. The circuit breaker pattern stops repeated attempts to a service that is failing, which helps to avoid further errors. Fallback methods give an alternative plan when a service fails. The retry pattern retries the request, again using delays to reduce pressure on the system. Bulkhead and timeout pattern keeps failures in one service from affecting others and prevent long waits for responses. What is the circuit breaker pattern? The circuit breaker pattern is like a safety switch for microservices. If a service starts to fail often, this pattern stops more requests from going to that failing service. This prevents further problems and gives the service time to fix itself. After a set time, it checks if the service is working well again before allowing requests to go through, helping to keep the system stable. How does bulkhead pattern help in improving system resiliency? The bulkhead pattern makes a system more reliable by dividing it into separate actions. Similar to compartment in a ship, if one section has a problem, it does not affect the others. This separation helps to ensure that if one part of the system fails or gets too busy, it won't drag down the entire system. Each section has its own resources so that they don't overwhelm each other, keeping the system stable. Can you explain the retry and backup patterns? The retry pattern means trying a failed operation again, which can help to solve temporary problems like network glitch. Backup pattern adds waiting times between these retries, increase the wait after each attempt. This helps to avoid overloading the system while it's still recovering. Using these patterns together helps the system handle failures smoothly by not rushing to retry, giving everything is a better chance to get back to the normal.